All right, in the previous example, we solved the case of simple root, okay, and non-repeated. Simple root and non-repeated. In this video, I want us to look at this example where we have a complex root. Let's see. If we follow the step as I mentioned, first step, we want to introduce this. If you do that, you have found P of lambda is equal. You don't have to differentiate each term and just substitute here. So this is the second derivative. I know that this second derivative will come with e to the power. This second derivative will come with lambda squared times e to the power lambda x, okay? And here will come with e lambda times e to the power lambda x. So I can just write it directly without going through differentiations, first order, second order before I substitute here, okay? So this is lambda squared minus 2 lambda plus 3 is equal 0. All right, to solve this, we can use a discriminant method. This is minus b, so this is 2 minus square root of b squared is 4 minus 4ac. This is 12 over 2a. So this is 2 minus square root of minus 8 over 2. And this is, if you simplify this, this is 1. This divides this, and this one will be root 2i. All right, this is what we obtain. The solution to this is y equal e to the power. If we substitute this here, this is 1 plus minus square root of 2i. But this is complex. We can't just leave a solution like this. It should be real. The solution should be real. What can we do? So we have to write it in this way, times x. So this is the solution, but this solution is not real. It is complex. All right. If we divide this into two parts, so this is e to the power x. If we multiply this times e to the power, let's say plus minus square root of 2i, okay? Remember that e to the power I theta is equal cos theta plus I sine theta. What does it mean? If I want to substitute here, we have the following: e to the power x times cos square root of 2x, there's x missing here, plus I sine square root of 2x. Use the bracket. All right, at this stage, if you take this, you multiply by this gives you the first solution. This is, let's say y1 is equal e to the power x cos square root of 2x, and y2 is e to the power x sine square root of 2x. So we have the first solution, we have the second solution. So to write down now the general solution, we write this as a linear combination. Is stated here. Write down the solution as linear combination of linearly independent functions, okay? So this is a times y1 e to the power x cos root 2x plus b times e to the power x sine 2x, where a and b are real. All right, this is the solution. So take note of this. This is very important. Every time when you solve the characteristic, the auxiliary polynomial, if you obtain lambda is equal alpha plus I beta, so this is complex value. The example is what we have here, okay? So when we solve, we obtain this form. The general solution is the following: y is equal e to the power alpha plus I beta x. So this is y equal, if we follow the same procedure, if we use this formula, this is y equal a e to the power alpha x cos beta x plus b times e to the power alpha x sine beta x, okay, with a and b rule. All right, this is the general formula. So every time when you solve and obtain, you solve the auxiliary polynomial and obtain complex root, okay? So if you can obtain complex root or this form, then make sure that the solutions look like this, okay? If, for instance, this is an example, if I solve a polynomial and I obtain lambda equal 2 plus minus, let's say, 10i, then what is the solution here? Just use this. You know alpha, you know beta, you know alpha and beta. So here can be plus minus. It doesn't matter. Okay. So if it's this form, then y is equal a times e to the power 2x cos 10x plus b times e to the power 2x sine 10x with a, b in real. Or if you see this is another example. Let's take this. Example 3. If lambda is a pure imaginary, so this is pure imaginary, meaning that the real part is 0, right? Plus minus square root of 3i. How do you write this? So you still write the same formula, just that the exponential will be exponential to the power 0, okay? So exponential to power 0 is 1. So this is y equal a times exponential to the power 0, which is 1, cos root 3x plus sine plus b sine root 3x with a and b in R. So if you solve the auxiliary polynomial and you obtain complex solution, don't panic. This is the approach. Keep in mind that this is the general formula. You just have to follow this general formula, okay? So this is all for this video. In the next video, I want to explain the example of repeated root. So what will happen if you solve this and it is repeated? So you have this is the first one, and the second one is still the same. How do you proceed? So if you want to know that, follow me in the next video. Thank you.